Okay, let's go. Hi guys, my name is Maxim. I'm one of the mentors on this run of the school, and today we are gonna talk about Webpack. If you have any question during this lecture, you can ask in the chat, and I will try to answer at the end of the session. Okay, so today we're going to talk about Webpack, whose measure version currently is 5. We'll try to answer the following questions. What is Webpack? Why should we use such a tool like Webpack? And what problem does Webpack solve? We'll try to create a simple Webpack configuration as well. Let's start. What is Webpack? According to the docs, Webpack is a static module bundler for modern JavaScript application, which runs through all the code and its dependencies, starting from entry point, and joins them into a bundle. Let's try to consider this statement in parts. Static means that Webpack is made primarily for bundling JavaScript and other static assets, such as HTML, CSS, JSON, images, and so on. Module bundler means Webpack generates a bundle from source code written using ES6 or CommonJS module syntax. So Webpack is a tool that takes pieces of JavaScript and their dependencies and bundles them into a single file, or sometimes in several files, usually for use in the browser. And it was telling that there is Webpack documentation, obviously, which is available on webpack.js.org. So you can have a look at the docs. I even encourage you to get acquainted with official guide. Okay, this is the image from official documentation. It represents in a simplified way how Webpack works. There are two main stages of bundling: dependency resolution and packing. Starting from entry point, such as index.js or main.js. Here, this is file in the top left corner. And Webpack usually, we can specify this entry point, again, index.js or main.js in the Webpack configuration. And dependency resolution, its goal is to look for all the dependencies of source code and construct a graph called a dependency graph. This dependency graph consists of modules that your application is needed for working as expected. After this process, after dependency resolution, Webpack can pack and convert this dependency graph into a single file, which then the application can use. And important to say that Webpack, that with Webpack you can use the most modern JavaScript with the latest syntax, and Webpack transforms your code using special loaders to supported and compatible code for all browsers, including all versions. For example, Internet Explorer 11. Again, you write your code using, for instance, ES6, ES7, or the latest ECMAScript version, and Webpack processes your code and transform, for example, to ES5 syntax, which is supported by many browsers. Okay, let's talk about the advantages of using Webpack. Why should we use Webpack and what problem does it solve? Of course, you can avoid using Webpack, and bundle your application on your own, but such tools like webpack fairly simplify application bundling, so developers can focus on business logic development. And what problem does webpack help us solve? First of all, webpack helps bundle JavaScript and static assets. To illustrate this, imagine you're bundling a web application which is made up of multiple JavaScript files. We could add JavaScript files into HTML via script tags, like this in the left picture. But each file requires a separate HTTP request, which is 5 different requests in order to get your application started for this particular example. So it would be better and easier if we can combine all 5 files into only one, like in the right. And webpack does it for us. Additionally, webpack helps manage the dependency relationship and load your assets in dependency order. The following challenges appear when we try to add multiple scripts to HTML. How do we maintain the order of the files? How do we prevent naming conflict between files? And how do we define any unused files within the bundle and remove it? All of this can be solved if we know the relationship amongst each file. And using common.js or ES6 modules provides a natural way to specify relationships between files and allows webpack to bundle application efficiently. But to help webpack organize its work the most efficiently, it's better to use such a type of module system like ES modules that have been introduced in ES6 version of ECMAScript. And here the example of using common.js and ES modules. Okay, next advantage, it's using loaders. Webpack can transpile code with the latest features to ES5 syntax to enable all browser support. And this in the picture on the left side, you can see that we are using spread operator, the nullish coalescing operator, and arrow function. Old browsers don't support this syntax, so we need to transform this modern code to a backward compatible version of JavaScript. And it can be done using webpack. For instance, webpack Babel loader, which can first transform syntax, and second, polyfill features that are missing in target environment. And on the right side, you can see the result of transpiling. For example, you can see that spread operator was transpiled to expression with concat method. Nullish coalescing operator was transpiled to this difficult enough expression, and arrow function was transpiled to usual JavaScript function, again using Babel plugin. Okay. Also, webpack allows developers to run a local development server to watch for changes in the process of development and update the page automatically, so-called live reload. We will talk about this later in practice. Also, webpack using plugins, webpack minifies our code in production mode to reduce bundle size and speed up loading application. Here in the picture, you can see Webpack transform our code to an unclear mess of code that is obviously not for humans, but it saves space and time. Next advantage it's tree shaking. Webpack perform tree shaking in the production mode. Obviously, we should say what this term means. Yeah, tree shaking is a term commonly used in the JavaScript context for dead code elimination or dead code removal. It relies on the static structure of ES6 module syntax with expression import and export, with statement import and export. So tree shaking usually works fine with ES6 modules. Next advantage, it's enabling micro frontend approach. Micro frontend is a wide topic itself, so I will just say that it's an architectural approach that allows you to design your application as a set of standalone components that can include their own interfaces, storage, logic. Teams can develop these mini applications independently and compose them in the browser. Webpack 5, which version we are considering now, introduced the module federation feature, which helps in building micro frontend architecture. Obviously, it is an advanced technique, and not all the front-end teams use it now, at least. But at least you have already learned about such an approach. And this slide represents all the advantages mentioned before, but in one place. Okay. About configuration. Out of the box, Webpack won't require you to use any configuration file, so you can run CLI command and everything might be even working. But zero config has limitation. If you don't have a config file, Webpack will assume the entry point of your project is source src index.js. And also Webpack will output the result in this main file, which will be minified and optimized for production. So if we want to have more flexibility, we need to use our own Webpack configuration. And next slide represents a simple Webpack configuration. Usually, configuration is placed in a JavaScript file named webpack.config.js. This is the place where Webpack looks for the config by default. You see that config represents an object that is exported from this file, like this, model exports. Here we're using common.js modules. The object consists of such fields like entry, output, mode, plugins, and module. Also dev server. And next slide, we will talk about entry. Again, this is property in the Webpack configuration. So Webpack usually starts with an entry file, and from there it bundles all the code needed for that entry file. An entry point indicates which module Webpack should use to start building its internal dependency graph. For example, here entry point is the file index.js in the src folder. But it's possible to specify several entries like this using array and like this using object. output. This property tells Webpack where to emit the bundles that it creates and how to name these files. For example, here we want our bundle to be placed in a dist folder with file name bundles.js, file name bundle.js, and folder dist. Also, we can form a dynamic name as substitutions, which can consist of hash, content hash of compilation, ID or name, to give each bundle a unique name. It usually helps to avoid issues with cached JavaScript in browsers after releasing a new version of application. Okay. Next property in the configuration is loaders. Webpack can process only JavaScript and JSON files by default. And loaders allow Webpack to process other types of files and convert them into valid modules that can be consumed by your application and added to the dependency graph. At the high level, loaders have two properties in the Webpack configuration. Test property. This property identifies which file or files should be transformed. Here we usually use regular expressions. And use property, which indicates which loader should be used to do this transforming. Loaders can be chained like this to loaders in the array. And it's important to know that chain is executed in reverse order. So here, firstly, CSS loader will be executed, and then after that, style loader. Loaders can be synchronous or asynchronous. Loaders run in Node.js environment, so we can do everything that's possible there. And sometimes loaders can be configured with an options object, like this for file loader. And this slide represents a list of commonly used loaders. These loaders can process JavaScript files, TypeScript files, CSS, Sass files, and assets. Okay. Plugins. While loaders are used to transform certain types of modules, plugins can be used to perform a wider range of tasks like bundle optimization, asset management, creation of HTML file, and for example, injection of environment variables. So plugins are used for build process customization. And here, for example, in the picture, we're using HTML Webpack plugin to create index.html file automatically. We will talk about this plugin in the practice section later. And this is a list of commonly used plugins. Again, HTML Webpack plugin creates HTML file automatically. Mini CSS extract plugin extracts CSS into separate files. Cursor Webpack plugin uses cursor to minify JavaScript. And bundle analyzer plugin is usually used to visualize size of Webpack output. And by the way, we will consider this plugin in the practice later. Okay. The next property from configuration, it's mode. By setting the mode parameter, to either development or production, you can enable Webpack's built-in optimization that corresponds to each environment. The default value is production. Also, there is a none option, a none mode, which is available to turn off any optimization. Okay, and this slide shows a comparison between development and production modes. For example, we ran our build like this in production mode and in development mode, and you can see that at the top of the slide a screenshot with development mode and at the bottom with production. And first of all, I would draw your attention to the size, which is more than 6 kilobytes in dev mode and only about 700 bytes in the production mode. So this is the simplest evidence of the differences between modes. I believe you understand why such modes exist, but anyway, I have to say that dev mode is usually used in the development process. Production one is used when we want to run our application on the web server with maximum of optimizations to provide an application to the world, to the users. Okay, next property in the Webpack configuration is dev server. Webpack dev server is a usual Node server, Node.js server, to serve a bundle. It can be used to quickly develop an application and provides a live reload feature. It can be configured through a set of options in the configuration. To use this dev server, we need to install the Webpack dev server module. And here you can see steps to get started with Webpack in practice. You can see we need to install both Webpack and Webpack CLI packages, and additionally Webpack dev server if we want to run an application locally. And then after installation, we can use Webpack. Optionally, we can add a new script to the package.json like this in the section script. So we can create a new script with name build and provide Webpack command for this script. And this is considered a good practice, but we can also run just Webpack command directly in the console. So after that, we can just run npm run build or Webpack, and then Webpack will emit output files to the corresponding folder. We will look at this in practice later. Okay, what about alternatives? I think it is worth mentioning other bundlers which can be used instead of Webpack. And I would highlight such bundlers like Rollup, Parcel, and ESBuild. You can go to the corresponding sites of these bundlers and check them out on your own. And thank you for the joining and for watching. And now I would like to move to the practice. We are going to create a small Webpack configuration and compare development and production mode as well. Okay, I hope you can see my screen again with ID. And let's start. Firstly, we need to initiate package.json by running npm init -y command. So let's start. You can see that our project that I prepared before doesn't have package.json file. So let's create this by running npm init y command. Okay. Now package.json file appears. And in order to install webpack, we need to run npm I -d. Yeah, this command in order to install webpack CLI, and webpack dev server. Let's install them. Okay. It seems we already have, yeah, in package.json these dependencies appeared. So now after installation, we have dev dependencies like webpack. You can see that current version is 5, I mean measure version, webpack CLI and webpack dev server. Okay. As I said, I prepared some code and there is index file and there is util files with some utils functions. Let's try to add to our package.json to script section command in order to webpack can build. So first command we will name build, and it would be webpack. Okay, and let's add additionally to command like build prod and build dev. It means this command will be run webpack in production mode, build prod, and this one in dev mode, webpack mode development. So let's try to build command and we'll see. Okay, npm run build. Okay, you can see that webpack asks us to add mode because in this case by default mode is production. And after running, you can see that this folder appeared and main.js file exists. And you can see that again, because of this production mode, webpack minified this code. And again, I would like to draw your attention that we don't have webpack configuration still. So webpack assumed that our entry point is index.js, and webpack emits this bundle into this directory. Okay, next let's create webpack config to customize the process. Okay, before creation, I would like to run this command again. Webpack build, for example, dev mode. and we can see how our file main.js looks. You can see that for dev building, webpack doesn't care about size of code, because it's development mode, so we can see a lot of stuff here. Okay, let's try to add webpack configuration. Let's create new file, webpack.config.js, but not here and here. Good. And what we should do, it's I just copy paste in order to speed up process. So we should require path because we are using it here, and we assume that our mode is production, our entry point is source src index.js, and output will be bundle.js. Okay, let's try to remove, or just let's try to add clean property to clean previous output. And again, we run our application, run our webpack, webpack prod. And you can see that now our file is called bundle.js, not main.js, but bundle.js. Cool. And now we can even no, I wanted to say we can serve our application, but not yet. In order to serve our application, let's add a new plugin which will create an index.html file automatically and inject into this file our bundle.js file. For this, we need to install webpack HTML webpack plugin. So let's try to install npm e -d HTML webpack plugin. And additionally, we need to use this plugin in our webpack configuration. Let's do it. Firstly, we require or import this plugin, and secondly, we just add this plugin in section of plugins like this. Okay, now we can rebuild our application. Okay, you can see that after building, you can see that index.html file was added to the dist folder, and additionally our bundle was injected to this file. Let's try. Yes. Okay, we can run in dev mode in order to see that clearly. Yeah, you can see that this file, I mean index.html file, has a script with bundle.js file. Okay, now we can even try to open this file in index.html. Let's try. And you can see that we can we see hello webpack header, which is presented on this page. Okay, but let's add the possibility. No, before I wanted to add file loader, but before I suppose we can run our application using webpack dev server. So in order to do this, we should add additional script to our script section. This script will be called start, and we will run the script in order to serve our application. Let's start. npm run start. Okay, you can see that the same result, but webpack dev server serves our application automatically. We don't need to open this page manually. So now we have working application and running it using webpack dev server. Okay. And next step I would like to do, it's just a second. Yeah, we have some assets and we would like to use it. For example, now, if I want to use this image, I mean this one. Yeah, I would like to use this image on the page. In order to use it, I can import it from assets folder, and then I want to create element image and give them link to this image. So let's try to build webpack after these changes. By the way, yeah, you can see that we got error because webpack watches our changes, and you can see that webpack cannot parse this image because we need to install file loader. Okay, let's try to install. Just a second. npm e file loader. And -d. Okay, and additionally, in order to use this loader in the webpack configuration, we need to add this code. This section module is used to put different loaders, and here in the rules property we put our first loader named file loader, and let's try to rebuild our application. Perfect. You can see that now we got our image, and that's nice. Okay, what if we want to stylize our application using CSS? For example, here I'm prepared some styles. In the styles folder, very simple styles. And we would like to use these styles, so we need to uncomment this line. And yeah, again, these styles for h2 color class and image square. These classes are used for this header and this image. So let's try to rerun our application. No need to rerun because Webpack dev server did that for us. And again, we got error. In order to fix this error, again, we should add a couple of loaders. Let's try to do it. We need style loader and CSS loader. Okay, installing. Perfect. Let's try package.json. Yeah, you can see that CSS loader was added and style loader was added. Perfect. And now we should update our configuration to add these loaders to rules section. Okay. You can see that we want to test all the files with CSS extension. So Webpack will handle only CSS files. And to handle these files, Webpack will use firstly CSS loader and then style loader. Okay, let's try to rebuild our application again. And you can see that we got our styles. Now color for this header is changed, and additionally we have a border for image. So our styles works. Let's try to inspect a little bit and maybe we can do this. Yeah. So style loader added our styles into head section into style tag. You can see that. And additionally, in order to put our styles in separate files, we can use CSS extract plugin. And if we use it, we will get these styles separately in the CSS file. Okay, we have CSS loader, and now let's try to add JavaScript loader. You already know that Webpack can handle JavaScript files by default. So we don't have here special loaders for JavaScript, but everything works. So we don't need to add this loader. But like I mentioned before, usually we need to transpile our modern JavaScript to, for example, ES5 version to be compatible with different browsers. So let's add the Babel loader, which will transpile our JavaScript. For this, we need to install Babel loader, Babel presets, and additionally Babel core. So let's do it. Here we are installing Babel core, Babel loader, and Babel preset N. Let's try to wait for a while. Okay, and after that, of course, you already know that we need to add this loader, which we installed right now. We should add to configuration, obviously. So let's try to add like this. Again, this object tells Webpack that we should handle by this loader, by Babel loader, we should handle only files with extension JavaScript, so JavaScript files, and additionally, we would like Babel to use a couple of presets. Sorry, one preset, this one, and additionally, we want this loader excludes node modules folder and only handle our files. Okay, let's try to build our application again. Yeah, that's work, and we can even investigate code, JavaScript code. Bundle.js. Yeah, you can see that it's difficult to find our code, but we can try, for example, by looking for this console log. Yeah, you can see that Webpack uses eval. Yeah, don't use eval, but in dev mode, Webpack uses this function. Okay, what else? One more thing I would like to mention. And I would like to tell you about the Webpack bundle analyzer, which can be helpful when you want to find what modules make up the most of sites. You can see that here I'm using loaders. By the way, we need to install this one module. For example, like this, npm e loaders. It needs to show you example with the Webpack bundle analyzer. Okay, and what I'm using loaders to get tail. So I am using a tail function, tail helper from loaders, and here, yeah, I'm using here. So I uncomment this line, and firstly let's add Webpack bundle analyzer. In order to add it, we just should install this one. So let's install. Okay, and additionally we need to add a script in the package.json file. In script section, we just added analyze script, which will be used Webpack bundle analyzer to visualize results. So as you remember, I uncomment this line, and util object has getTail method, getTail function to return all the elements of the array, but the first. It's just a random function from Lodash I would like to use. So let's try to run webpack bundle analyzer. So npm run analyze. Yeah, after running this command, we can see that Lodash library takes about 500 kilobytes. Although we just use the only one function, tail, that, as I said, returns all the elements of array but the first. And if we Google this problem, we will able to fix it by changing imports like this. So we just change imports and we import this function tail directly from Lodash tail. Okay, let's rerun our bundle analyzer. Again, you can see more than 500 kilobytes, and here we can see that tail takes almost 500 bytes. Yeah, so as we are convinced, Webpack bundle analyzer can be useful for developers, especially when some teams, some developers can problems with loading, with performance. So have a look at this package when you meet a problem with bundle size. And yeah, I assume that that's all I wanted to say today. Again, thank you for joining and watching. Yeah, that's all. Anna?
Seems there are no questions, so thank you a lot for this lecture.
Thank you.
Nice evening for everyone.
Bye.